Hello everyone, my name is Mayron and welcome back to episode 7. We haven't made a video since the last expansion, now that we're on Legion and nearly at patch 7.2, but as I record this we're still on patch 7.1 and a few things have changed, so I'm going to kind of explain, to begin with, what I've altered in the project code from the last episode. Now as a recap, what we did is we created a file and just flooded it with loads of widgets and embedded it into a XML template to gain access to Blizzard user interface elements. So this time, I want to make use of namespaces. Now namespaces are just a variable which basically spans across an entire add-on only, and you can add things onto the add-on namespace in order to share variables between files. So now let's open up the project from last time and you can already see a major load of differences. So these Lua files, config, init and timer, they have their own namespace that is accessible only to this add-on in this file. But let's just discuss what I've changed. The last episode we created an add-on called MUI Buffs. Now I've renamed this to Aura Tracker because honestly, the add-on that I had in mind was supposed to track buffs and debuffs. Now in the World of Warcraft universe, we refer to these as auras. So auras can be buffs or debuffs. And the idea is to track what we have gained on the actual buffs and debuffs frame of the Blizzard user interface. We're not trying to replace it, but we're trying to track things using like timer bars, or you can have a different mode to track an icon with a timer which you can sort of position anywhere around wherever you like, just to track the duration of how long it has left until it expires. I think this is a great idea for a project because we can show you how saved variables work, how databases work, how we track certain things in the combat log, and different script handlers for the different user interface elements we're going to create for the configuration menu. So overall, this sounds like a really good beginner's project. So the old core.lua file has been replaced by the init.lua file, and inside of the TOC file, we can see that the order of execution for these Lua files, the config and timer is going to be loaded first, and then right at the end the initializer, the init.lua file, is going to be the last one to be registered and executed, because this depends on all of the Lua files. So the config and timer Lua files aren't actually going to execute any code on their own. They're literally just going to store functions and objects which we can use. Now this is a far better, superior way of organizing a project, because you don't have any issues of what should I activate first. It's all done in the initializer. That's the thing that's going to trigger the project. So an incredibly important thing to take from this is that the interface number is different. This represents the patch that we're on. So far we're on patch 7.1 or 7.01, I don't remember, but it needs to be exactly like this, 70100. In the last episode, I think it was on 60200, so make sure you change that, otherwise when you try and load it in World of Warcraft it's going to say it's out of date, and it won't let you use the add-on. I've changed the title to Aura Tracker, and the saved variable is Aura Tracker DB, because in the future this is going to hold and store our database. If we go into the config file, you'll see here that I've created a defaults table. Now this is our artificial database. This is the thing that's going to be stored in a saved variable. However, for now I don't want to talk too much about databases and how to really create a very powerful database library or anything crazy like that. I'm just going to create something fake just to store our defaults table inside of. So we have a theme and it has the RGB color values. It's important to note that World of Warcraft uses a range of 0 to 1 to represent color values. Usually in web design you have up to 255, so if you go onto a website like W3 Schools and use their hex color wheel, you can get a bunch of RGB color values, but they're going to be up to 0 to 255, where 0 is black and 1 is white, or in this case 255 is white. So what you can do is divide all of those three numbers by 255. If you do this, then you get the right digits for World of Warcraft, 0 to 1. So as you can see here, I had 204 and I divided it by 255 and I got 0.8. Now this is the code in our previous episode. You can see it's exactly the same, apart from I've just added some comments. I've changed the name of the save button to save BTN to match the rest. Nothing really that stands out too much. However, the setPushedFontObject has been removed from the API, and I couldn't find any documentation on this. So maybe it didn't even exist, but I thought it did. But oh well, I guess it's not a thing anymore, so remember to remove this line. Now the other thing here, setDisabledFontObject. Usually you could set this to a blank string and it would completely remove the disabled font object. This is no longer the case, and you have to supply it with the official name that Blizzard have designated for a disabled font object, or you've created one yourself. Anyway, the point is you have to supply it a name, so you can't just remove disabled font objects like this anymore. So for now, we're not really going to need it anyway, let's just remove it. So everything else is the same, apart from here, it says UI config hide, because we want to have it hidden by default. We don't want to show it as soon as it's created, and then we're going to return it. Now this is optional, but I'll show you the reason why we return this. It's not local to this function, and you can still use the UI config object, because up here you can see that we've declared it here and not inside of the function. So as soon as you activate create menu, you could just use this object. You don't have to return it, but I'll show you the reason for this. Inside of config toggle, this is going to be the thing that toggles it, meaning it's going to show or hide the menu. So remember that by default, it's going to be hidden. So this decides whether it should be shown or hidden. So if you use it once, it's going to show it. If you use it a second time, it's going to hide the menu. So it's either going to use the object or it's going to create the object using the OR keyword. Now UI config is going to be set to nil at the start, so you're going to have to create it first. Then the next time UI config will have a value because we've assigned it right here. UI config equals the frame. So we're going to get the menu, it's only going to ever create it once, and then it's going to set shown, and it's going to invert what it currently is. If the menu is shown, it's going to say not is shown, meaning that it's hidden. So true becomes false and false becomes true, and we're going to set that to shown depending on what this returns. Another thing I want to mention, one more thing about this file, is that it's very bulky. You don't really want to have such a long, large function method. So what you can do here is, instead of creating all the buttons individually, you'll notice that there's a lot of things in common. These two lines are exactly the same, that's exactly the same, and setPoint has these three things are different, that's different, and the name is different, but that's the only thing that's different. The create frame, that's the same as well, so it makes more of a sense to put this inside of its own function. So we're going to remove these. So as you can see, now it's a lot smaller. And up here, I've already created the create button function. It takes point, relative frame, relative point, the Y offset, and the text, because those are the only things that are different. The rest of the code is the same. So it's going to create the local button, local to this scope inside of the function, until we return it. And now we can just return it and store it in any variable we want. We can do the same with slider and check button, but for now I'm just going to leave it as it is. I'm going to leave that up to you if you want to make it any more efficient. So that explains this file. Now namespaces, like I said, you automatically get given two arguments which is passed to a file. So you can think of a file as like its own function. The World of Warcraft system automatically gives you the name of the add-on and the namespace. So the first argument is actually called the add-on name, but I set it to a dummy variable because I just don't really need to know that this is the Aura Tracker add-on. You don't really need to use this very often. And the second argument that comes from this variable argument list is the namespace. I like to call this core, but maybe you just want to call it NS or namespace. It doesn't really matter. And by default, it is a table which is shared between every single Lua file in the add-on. As you can see here, we've got the 3 Lua files, so each one of these has access to this core namespace table. And config is executed first. This is really important to know because that's the thing that's going to be the first file which has the opportunity of creating objects and shoving them in to the namespace. So don't make the foolish error of trying to use objects which you have created in a timer.lua file inside of the config Lua file, because it's not going to be created just yet. So the first object I'm going to shove into that namespace is config. This means that all other Lua files have now access to config toggle, config get theme color. The next thing that's executed is timer. Now this is going to be the thing which basically creates these timer objects. The reason I decided on the idea of this project is because eventually these are going to be meta tables using object inheritance. So basically object-oriented programming brought into the Lua programming world. So that's going to be a really complicated thing and I'm going to explain it later. So this is going to create a bunch of timer objects or instances of the timer class. and then you can use things like the update method and destroy. So you can destroy an object and you can update it, so update the timer, meaning that we can update the duration of buffs and debuffs, but the destroy method is kind of tricky. In World of Warcraft, you cannot destroy frames. Once you create a frame, it can no longer be destroyed. You can't remove it from add-on memory. This is something you're going to have to really pay attention to because it's important to recycle it, meaning that we set it to like destroyed, we put it somewhere inside of a table, and we can pull it out again using a sort of stack implementation like I've mentioned in another episode. And it's also created a timer object and it's going to store it inside of the namespace so we can use it anywhere else in the file system. And now finally, we're going to be talking about advanced slash commands and how to handle them. So let's just close this for now, that's going to be really complicated. We're going to access the namespace, but we're not really going to use it just yet, but we are going to create some basic namespace functions. So we have the print, and we have the init, the initializer, which is going to be registered inside of the namespace object directly, and we're not going to shove it inside of an object within an object, it's just going to be on the top level of the namespace. So as you can see, these three things here are the helper development code that we had in episode 6. We always kept it at the top of the project file, which just lets you use the arrows in the chat edit box, meaning that when you have the edit box open, you're about to send a message, you can use left and right to skim through it. And we registered a quicker reload UI command, /rl. We also registered /fs to show the frame stack tool, which is the Blizzard tool for seeing what frames are called, user interface elements inside of World of Warcraft, what they're called. But the added addition to this is that we've got this new slash command that we've registered. So let me just explain how a slash command is registered in World of Warcraft. The first part of this global variable is called /_. This is important because Blizzard is going to find this and then it doesn't know what this is, and then it's going to also check that it's the number at the end of it. This number represents the ID which points to an alias which points to a function that handles a slash command, where the alias is the /blank and the ID is the number of aliases that point to the same function. So, Aura Tracker, you can see that this is the same name as what we attach onto the /command list. /command list is another global Blizzard variable, and it's going to hold a list of all of the keys to function pairs. So this is our key that we've created ourselves, and this is what's going to be found just here. And Blizzard is going to see that this is the first slash command, and we've registered this as /at. And Aura Tracker points to the handle /commands, which is a function that we create. It's a local function. So if we go up here, you can see I've already created it just here. So string str, this is going to basically hold a string which represents anything else that we type after at. It needs to have a space. So if you type /at hello, for example, in World of Warcraft, not in here, but if you type that in World of Warcraft, then that's hello is going to be saved and put into str, and anything else that basically trails on after this. So this crazy function here, which looks extremely complicated, this is going to check and find for us the correct response to handle this /commands that we type into World of Warcraft. So if the user types /at space config, it's going to cause and activate this function. It's important to note that a command has to point to a function, so core config.toggle is pointing to a function. However, it's really important to notice one key difference. I've used a dot here instead of a colon. I couldn't do this here because this is basically saying call toggle on the config object, and the config file just here, it's going to be assigned to whatever is returned by this function. Now to avoid this, I could have used a wrapper function. This is fine because it's basically saying we're going to assign a function to the config key inside of the commands table. But I don't really like this myself because it's a function within a function. Whoops, I accidentally forgot my colon just there, remember that bit. So instead of that, we're just going to supply it with the address of the function itself. So this is going to call the config toggle function, and notice that it's going to call a function from another file using the namespace because we have access to the namespace and we shoved it inside of the namespace, as you can see just here, core.config. So it's important to note that you cannot use the self-referential keyword, and if I put self instead, like just here, then it won't know what the heck we're talking about. So that is a typical beginner's mistake. So how the handle /commands function works, it basically looks at the commands table and it keeps finding nested tables until it reaches a function. What I mean by a nested table can also be thought of as a subtable, meaning tables within tables. As you can see here, example, this is a table inside of another table. It's going to keep going down and down the rabbit hole until it finds a key which is paired with a function, and then that's the stopping point. Once it has found the function, it's going to call it, and if there was more arguments passed to this /command, then it's going to put them inside of the function parameter list. Now, as soon as you log into World of Warcraft, you'll notice that it says Aura Tracker, welcome back, character name. This is because at the bottom of this function, the initializer, it's using core print, welcome back, unit name, player, which is us. And in previous patches, if you could remember, there used to be some system message text, which was printed into the chat window in yellow. For some reason, this current patch there's no system message, but if there was, then you would notice that Aura Tracker is actually printed below the system message. Now, if you recall from episode 1, I said that if you print outside of any event handler, like an event handler handling player entering world, then it would actually print on top of the yellow text. This is not the case in this scenario because we've actually added this inside of the initializer. And this function, the initializer, is actually registered with a register event add-on loaded. Now, if you remember, I did say that saved variables can only be accessed once the add-on loaded event has occurred. So therefore, we need to register it. We need to register it so that we know it when it triggers, and as soon as it triggers, then we can use the core initializer function, or the core init function. So this is how you register an event. You create a frame, you don't parent it with anything, you simply create it. We're going to call this events, then you can register the add-on loaded event using this. Now, you can use set script for many things, like registering on-click events or on-leave, on-enter onto GUI components, like buttons. But for now, we're going to use the on-event script, and we're going to handle this event using this core init function. Now again, we didn't use a wrapper function, and we used a dot instead. This means that we can't use self, the referential key variable that's automatically passed to us, so keep this in mind, never use self if you're using dot, unless you're using wrapper functions and calling it explicitly yourself. So if we look at wowprogramming.com and look at the frame widget, we can see all of the methods that it has for that object. If you look down at the bottom, you'll see script handlers. Now these are all the handlers that you have access to. We are using onEvent. So you can see here, it has the event keyword, name of the event, so this is going to be add-on loaded, that gets passed to the function, and the ... is the variable argument list, which is another bunch of arguments that are going to be passed to the function depending on what event was activated. So in this case, we're using add-on loaded. So we need to have a look now at the add-on loaded event. So on wowprogramming.com, you'll see just here it says game events, complete event listings. And I didn't really have to use the find tool, but as you can see here, we should select this. And it says another argument that gets passed to it in the variable argument list, there's only one, and it's the name of the add-on that has been loaded. So notice that I'm not using self. Despite not actually calling it with the colon, self is going to be added implicitly and you can just use it. You don't actually have to specify it inside of the parameter argument list. However, self will not point to core. This is incredibly important. If you look at the documentation, self refers to the frame, and the frame that we created was called events. So if you do it this way, just like I've showed you on the screen, set script core.init, self is going to be assigned the events frame, not the core table or core object. So that's incredibly important to know because that's an error which I wasn't even aware of myself when I actually wrote this thing. I completely forgot about this, so I'd imagine that it's going to trip a lot of people up. So let's just use event and name, and use self if we want to refer to the events frame, but we never really have to do that. So, if name does not equal Aura Tracker, then we're going to return it and just ignore the rest of the code. We want to wait until Aura Tracker has been successfully loaded so that we have access to the saved variable called Aura Tracker DB that we registered inside of the TOC file. So the code gets executed first, and then eventually the saved variable will become available after the add-on has been loaded. Once it's been loaded, we have now access to it. We're not going to use it just yet, but it's going to execute all of this, and that's the reason why welcome back is printed after any system message has been printed to the console window. So before it's printed, it's going to register the slash command. And like I said, this function handle slash commands is going to help us point to the right function that we want to execute depending on what we type. So if here we've got example test and then we expected some other value, anything we want, and that's going to be stored as a string inside of the function as the first argument. So if we type /at, which is the shortcut or alias registered with the function, then it's going to find the example table, and then the handle slash commands function is going to keep continuing because it noticed that example was a table as well and it's not the final stopping point. It's going to find test because we have explicitly typed test, and it's going to say, oh, test is paired with a function, let's execute that function, and whatever trails it, like hello there, that's going to be passed as the first argument to the function. Now the reason it doesn't print all of the arguments like hello there is because I've just noticed up here I'm only collecting the first one. If I wanted to print everything, you should change this to a variable argument list because we don't know how many additional arguments the user is passing to the function. Then we can use a Blizzard implemented function called toStringAll. This basically accepts a list of arguments, or a variable argument, or a var_arg as they're called, and it concatenates them and divides them by a space. So if we type that now, at example test hello there, and press enter, we notice that it's actually printing hello there, and it's actually reserved the space which is being supplied by the toStringAll function. So it joins a bunch of strings and separates them by a space. So let's go through this and explain it. Let's just print str or string so that you know what's actually happening. So as you can see on screen, the first argument, str, or string, that's a string itself which contains the three words example text hello. So this can be thought of as the arguments after the /at, the slash commands that we registered. So if the string is 0, then we're going to print core commands help. So let's just see what that does. At. Now there's nothing that follows at, so the length of the string should be 0. So as you can see here, it's printed list of slash commands /at config /at help, because the core commands help is a function just here, and it's just going to print this function right here, print, and it's going to use our fancy print function, which I'll explain after this, to print the help information. So this basically gets the length of the string. Now the string always has a length, so if it's something more than 0, then it's going to continue on to the rest of the file. So now it's going to look at the string that was passed to the function. Let's pretend it was example test hello. So every time it encounters a space depicted by these two quotation marks just here, it's going to split it and it's going to shove it inside of a table, this anonymous table right here. So this table is going to contain three words in this case. It's going to contain example, test, and hello, and it's going to ignore the spaces. Those spaces were just identifiers to split the string. Now it's important to note that if the user enters many different spaces, then the table, this anonymous table, is also going to contain a bunch of empty strings, which is why we have to once again check that the length of the string is greater than 0, meaning that it contains an actual word. If it does contain an actual word, we're going to shove it inside of the args table right up here. You could do this manually, or you can use the table.insert function. This is a native Lua object which contains functions of its own like insert, and basically it does a few more smarter things. Rather than finding the length of the table and inserting it at the end of the table by yourself, it will insert it automatically for you at the right place at the end of the table. And there's also table.remove, which kind of just does some maintenance work, like it cleans nil values and sort of shifts everything in a table one direction to the left if you remove elements in the middle of the table, things like that. So it's always quite a nice idea to use table.insert instead of doing it manually, and table.remove, unless you really want to preserve nil keywords. So if you wanted to do it manually, you'd find the length of the args table and then +1, creating a new index and assigning this new index to the arg value. Remember that Lua, all indexes start at 1 and not 0, unlike every single other language which usually starts at 0. So moving along, we now have an args table which is filled with three strings, example, test, and anything that we added afterwards, in this case hello. Next, we assign a variable called local path to core.commands. And remember that core.commands contains nested tables or key and function pairs on the top level, pointing to the functions that we want to find and call. So the basic idea here is that nested tables are going to relate and sort of represent the arguments that we pass to the slash command. So this is the reason why example was a nested table inside of the commands table, and why test points to a function. So the idea here is to find the nested table until we find the function that we need to call. So we're going to iterate using ipairs all of the arguments, these 3 words. So arg will become example, and then it will become test, and then it will find the function and then call the function. It's important to note that we're using string.lower, and you can see here that string is purple. This kind of means in Notepad++ that it's a native function or native object to the Lua programming language. If example was all in uppercase, or some of the letters were in uppercase and others were in lowercase, it's going to make sure that it's all in lowercase, so the user can type example all in caps, or capitalize some characters incorrectly, but it will still find the function and activate it regardless. So arg will be a lowercase version of whatever was the word. So if example is a key located inside of commands, which it is, then it will work, and this if statement will work. If not, then it's just going to point to the help because the user didn't really know what they're doing and have typed something incorrectly, so it's just going to print the help menu and then return out of the function. And now the second part here is using the type keyword, which is another native Lua function, because this points to it. This is a key, and path key is pointing to the value of that key. So if it points to a type, which is a function, like this one and this one are, then it's going to activate the function. If it's pointing to a table, which example is, then this condition here is going to return false instead of true. But if it is pointing to a function, we're going to call the function like this. But to make it a bit more nicer, anything else that the user has trailing afterwards, it's going to be passed to the parameter list. And to do that, we're going to use the select function. So args is the table. We're going to unpack the table into a variable arguments list kind of style. So unpack args is going to be turned into this pretty much. That's what unpack actually does. It turns a table and removes all the values from the table and adds them as arguments being passed to a function. So that gets turned into that. And now id plus 1 is basically finding, okay, so what ID are we on at the moment? So the first one was a table, so it's going to do this thing first. It's going to basically turn the path into the next table that we found. So now it's pointing to the subtable, meaning that ID now becomes 2. And then it finds the function, so remember that ID is now 2, so it's going to select the third parameter. So if unpack was this, then it's going to select the third parameter. So 1, 2, 3, so it's going to select the third argument. Now the main thing to take from this is that by using this line just here, we can change what is being scanned in this for loop. We can say that instead of using the roots table, if you find a subtable, use that instead, until you find a function. So the only thing left to explain is the print function. Now we're always using this special custom print function. As you can see here, it's getting the hex color value from self.config and getting the theme color. Now, the theme color points to our defaults table which we're using to represent the database. So if you look just here, get theme color is getting the RGB and hex color values from the defaults table. We are selecting the fourth argument which is returned by this function. String.format, like many other languages, uses a thing called regular expressions. Regular expressions are very complicated. It is used to inject strings inside of another string. That's the basic premise though. This special thing here is called the character class. The string.format function scans this first argument that we're supplied it. This is going to be the pattern. In the Lua programming world, it uses the percentage sign, and it's going to find the percentage sign by scanning each individual character. It's going to find that, and then it's going to see what trails afterwards. It finds an S, so it thinks, okay, this is expecting a string. Percentage S represents a string placeholder. If you had like a D or an F, depending on the language, I might be getting muddled up, but that's usually represents a number value. but because we're using %s, this says, okay, we need to find a string. And then it finds another one just here. So it records that, okay, this string should be injected with 2 other strings. So it knows that the next 2 arguments being passed to it have to be strings, and which in this case there are. So this is the first string, this is the second string. So you can think of this as being just a big concatenation. You could replace this whole line with concatenation, but this is a nicer way of handling it. Let me show you the equivalence of using concatenation rather than string.format. So, if you really didn't want to use this crazy string.format procedure, you could actually write this, but the reason we use string.format is because it becomes incredibly useful for times where you really don't know what strings you're going to be injecting into other strings, but also for times where the user wants to customize different strings or output messages. Now, the default chat frame is a widget. It's a global, constant, Blizzard supplied variable. Constant meaning that it's not supposed to change, and the standard thing for doing this is writing a variable all in capitals. It doesn't automatically do anything, it's just a traditional way of representing a constant variable. So default chat frame always points to the default chat frame in World of Warcraft, which is a widget. Now widgets, as we've discussed, have their own methods. We're using the addMessage method. So if you look at the WoW programming documentation, you'll see that the scrolling message frame has an addMessage method, and the message frame also has an addMessage method. So we know that the default chat frame points to a message frame or a scrolling message frame representing the chat frame. The default chat frame is always the first tab chat frame. So in this case, the general tab is the default chat frame. So now we can add anything we want to the default chat frame. So we're going to be using the string.join method. You might have noticed that I've changed this because it was using toString_all, which was redundant. So just ignore that. I'm using string.join, which is actually a Blizzard supplied function. You'd think that string.join would be a native Lua programming function, like it should show up as purple, but it's not. If it doesn't show up as purple, that means we're getting it from somewhere else, or that Notepad++ is just wrong, but usually it's very reliable, so it must be a Blizzard function. So anyway, the first argument is expected to be the delimiter. So string.join is going to get a whole list of random words or strings, and it's going to concatenate and join them all together, and we need to use string.join because we don't actually know how many values are supplied in the variable argument list. We just know that this contains a crazy amount of variables, we don't really know how much, but string.join doesn't really need to know the length of it, it's just going to join every single word together into one single string, and it's going to separate every single word using an empty white space character. All we need to know is that the first word that needs to be concatenated is going to be our prefix that we created, which is the Aura Tracker words just here, which is using a hex colored code and using the CFF, which is the thing I explained in episode 1, which basically renders to the World of Warcraft screen a string in a specified color. So this is going to create the Aura Tracker in blue using the getTheme color, and then it's going to take whatever else we send to the print function, and it's going to add that after the prefix, all split apart by an empty space, and it's going to add that onto the default chat frame. So just to recap, we've explained how the core.commands table is traversed using a for loop, and that is all done in the handle / commands, which we have registered with our alias, or the / command at inside of the core.initialize function, which also initializes after the registered event add-on loaded. So once that's been loaded, we check that the add-on that has been loaded, because this is going to be called for every single add-on that gets loaded, so it's important to note here that we are waiting for our add-on to be loaded before activating all the other stuff. Then we have used namespaces to communicate with the rest of the Lua files associated with the add-on inside of the folder. The timer Lua file we haven't accessed yet, so we haven't even touched this, we're basically just getting the project structure prepared. And we have used the config.lua file to access the defaults table. We have created a new method which contains our code from the previous episode, but we haven't actually toggled it yet. So let's just demonstrate that the toggle command works. And remember that in the commands, we have assigned toggle to the config command. So if you type /atconfig, this will activate the toggle function from another Lua file, and these Lua files are connected using the same shared namespace for that add-on. add-on. So as you see here, the namespace implementation worked perfectly. If this window has never been created before, it's going to create it and it's going to assign it to the UI config object. If we use toggle again, it's going to not recreate it a second time, it's going to use the same UI config variable reference. So if I type atconfig, it's going to call toggle again, and you can use this as much times as you want to keep showing and hiding it, or you can just press the X button, which hides it as well, because that functionality was supplied to us by Blizzard themselves, because we're using an XML template as explained in the last episode. So that demonstrates the use of a namespace to use code between different files inside of an add-on folder. However, this namespace only applies to this add-on. You cannot access the namespace directly with any other add-on unless you create some sort of global function and return it. So thank you very much for watching this episode. I'm sorry this might have been a bit long, and I'm sorry if this is a bit confusing because I did add a lot of new features and new things, but remember, this will all be available on GitHub. So if you follow the link in the description, you'll see the code, you can download it, you can type it yourself, copy it, do whatever you want to do, just make sure you understand the code. So thank you very much for waiting for episode 7, and I should have more episodes on the way. Thank you very much, this has been Mayron, and bye for now.